Uh, this review is about etching. Etching is to remove material identified by the lithography progress, and the etching target is silicon and silicon dioxide, silicon nitride, and metals. There it is etch profile. There are isotropic and anisotropic. Isotropic etching proceeds at equal rates in both horizontal and vertical direction. Anisotropic etching proceeds faster in one plane than in another. There are two ways to do etching. First, wet etching, and second, dry etching. Wet etching is too hard to control because etch rate is so fast, and it is normally isotropic. Dry etching is generally anisotropic. And there are four elements: figure of merit, etching rate, etch rate, uniformity, etch profile, and etch selectivity. AF is degree of isotropy. When AF is close to 1, it is anisotropy. On the other hand, when AF is close to 0, it is isotropy. And this picture has a high etch selectivity because the blue part is not etched. This part is wet etching. Wet etching has 3 steps. First, reactant transport. Second, reaction. Third, transport away from surface. Each step is dependent. Wet etching's etch rate is affected by temperature, concentration, and chemicals, and it is generally isotropic. And because too time sensitive, it is hard to process control. And this is dry etching's advantages and disadvantages. Advantages is direction, less undercutting, and better progress control, and ease of automation. And disadvantage is some gases are quite toxic and corrosive and need for specialized equipment. It is expensive. Dry etching has 2 ways. First is done plasma etching. Second is plasma etching. And this part is reactive ion etching, RIE. As you can see, progress in which chemical etching is accompanied by ionic bombardment. Wet etching and chemical etching has the property of being isotropic, and dry etching has the property of being anisotropic. Here, trade-off occurs. Etching rate is so high, and gas pressure is so high. Since the space of atoms is short, the Collins property is high, and then getting isotropic. And this part is DRIE. DRIE wants to a pattern of fall down. In this picture, SF6 more SF6 more silicon, and this SF6 strikes sideways. And then to solve it, Teflon based C2F ball is coated to make a shield, and then mold it again with SF6 and repeat this process. In the end, there are scallops.